All right, let's jump right into this explainer. If you're gearing up for the Cisco AI Technical Practitioner blueprint, or honestly, even if you just want to figure out the actual nuts and bolts of bringing artificial intelligence into a real-world production environment, you're in the exact right place. We're going to break down the fairly complex mechanics of AI workflows into clear, bite-sized, and highly structured concepts. Let's get to it. Now, what I find absolutely fascinating about this official 60-minute certification, the AITECH 810-110 exam, is that it's not just about high-level AI theory. Not at all. It actually tests your direct, hands-on ability to bring AI into production safely and efficiently. The blueprint covers a pretty massive array of competencies, everything from generative AI models to agentic AI. But here's the kicker. Passing requires you to prove you know how to actually govern these systems, not just, turn them on and hope for the best. And this breakdown shows us exactly where your focus needs to be. Notice that one specific 20% slice? We are focusing heavily on development and workflow automation, which carries a massive, massive weight on the exam. It basically shares the top spot right alongside generative AI and agentic AI. You simply cannot pass this exam without a deep fundamental understanding of how to automate and manage development pipelines. So here's our game plan for today. We'll start with the AITECH blueprint focus, then move into workflow design principles, tackle the resource constraints, discuss the prototyping trade-off, and finally wrap up with optimizing for success. All right, Section 1, the AITECH Blueprint Focus. We're zeroing in on Objective 5.3. So, Objective 5.3, it straight up tells us you must be able to explain AI workflow design and monitoring principles. Cisco requires you to understand both the architecture and the oversight. Think about it. When you plug an AI model into a development lifecycle, how do you track what it's actually doing? How do you know if it's succeeding or just completely hallucinating? This objective really sets the stage for the whole shebang. Moving right along to Section 2, Workflow Design Principles, or the Sequential Foundation. Okay, so how do we actually do this in the real world? Well, there's a very strict sequence here. Step 1, you've got to design the AI workflow for rapid prototyping. AI moves incredibly fast, right? So your cycle needs to support building and testing at lightning speed. But then, Step 2, and you cannot skip this, you have to immediately implement monitoring principles to track performance. Because rapid prototyping without a monitoring safety net, that just means you're moving fast and breaking things without even knowing why they're broken. Which brings us to Section 3, the resource constraints. This bridges Objective 5.3 right over to 5.4. Now, you and I both know that a perfect design on paper usually smacks right into a brick wall in the real world. To bridge the gap between that theoretical design and a successful prototype, we have to ask ourselves, what exactly limits our system? What physical constraints impact rapid AI prototyping? Because it's so easy to think of AI as this limitless, magical cloud brain, but actually, it's bound by very strict computational rules. And bam, that brings us directly to Objective 5.4, which introduces two vital elements, tokens and context windows. These are essentially the laws of physics for AI that completely dictate your project's viability. Think of a token like a piece of a word. It's the fundamental currency the AI uses to compute. And the context window? That's the AI's short-term memory. It's the absolute maximum number of tokens the AI can hold in its head at any one given moment to process your prompt and generate an answer. If your workflow design doesn't carefully manage how many tokens you're spending and how much of that context window you're filling up, your rapid prototype is going to crash hard. Let's dive into Section 4, the prototyping trade-off, the triangle of cost, latency, and quality. This right here is the golden triangle Cisco expects you to balance on the exam. Let's break down these metrics. First up, prototyping cost. Because you pay per token, maxing out your context windows burns through your budget incredibly fast. To put that into perspective, processing massive documents in every single prompt can turn a $5 prototype into a $500 problem literally overnight. Next is latency. Stuffing massive amounts of data into the context window forces the model to process all of it, which slows down generation times and seriously frustrates your users. But here's the catch. Look at output quality. To get highly accurate outputs without those hallucinations, you usually need to provide a lot of background information, which means, you guessed it, spending more tokens. So pushing for maximum quality inevitably increases both your cost and your latency. And that is exactly why the workflow monitoring we talked about in Objective 5.3 is so absolutely crucial. Finally, Section 5, optimizing for success. Let's tie this whole blueprint together. So check out this direct quote from the blueprint. Cisco explicitly demands that you can describe how token usage and context window management affect prototyping cost, latency, and output quality. This proves that workflow automation isn't just about, writing clever code or connecting a few APIs. It's about mastering resource economics. You're functioning as an architect. You have to decide when a slight dip in output quality is actually worth a massive saving in cost and latency, or vice versa. So, as you wrap up your study sessions and get ready for the exam, I want you to keep this one big question in the back of your mind. Are your AI workflows designed for scale, or are they just built for bottlenecks? Because at the end of the day, mastering that delicate balancing act between token costs, system latency, and output quality is exactly what separates a theoretical novice from a certified production-ready AI technical practitioner. Go take a hard look at your own workflows, and I will catch you in the next explainer.